Now we are discussing about content cost function, means a portion of the cost function. We are discussing about this one. We have already discussed about the cost function for the neural style transfer. This cost function is consisting of two parts. One is content cost function and style cost function. Now we are discussing about content cost function. Let's take an hidden layer L. By using this hidden layer L, we are computing the content cost. You have to make sure that the hidden layer should not be, we should not consider the second layer or the third layer, initial layers. If we consider the initial layers, then there might be a problem that in the we get the similar, the generated image will be similar to the content image as it is. The copy of the content image can be observed in the generated image. So in order to avoid that, because there will not be any style will be transferred to that image, in order to overcome it, we are going to the deeper layers. And you should observe that the layer we are selecting as a hidden layer should not be very much deep. If we take the very much deep layer, then the content we are using, the content we are using, now when we are selecting that layer as a hidden layer, that might give a very dark pixels. So we have to avoid these two cases. We should not select the initial layers and we should not select the very deep layers. We can select in between, either initial or deeper in between we can select, such that it will give a very good value for us. We are using a pre-trained ConvNet that may be VGG 16 or VGG 19 we can use for this purpose. Let's say the activation function ALC and ALG. These are the activations of the layer L on the content image we are giving as an input. And the second one is example, the generated image. These are the activation layers. Now with these two activation layers, the activation units in these two layers, one is due to the content image and the second one is due to the generated image. If the activation units of these two layers are similar, then both images have the same content. This concept was discussed in the paper called A Neural Algorithm of Artistic Style. This was published in 2015. We are taking the concepts from that paper. So finally, the content cost function, it is nothing but we are defining this as J content C comma Z. So here we are taking the difference of the activation units. We are taking the activation unit of the content image ALC and the activation units from the layer L of the generated image. We are finding what is the difference between these two activation units, and we are taking the normalized square, which is nothing but we are taking the individual squares, the difference squares, and we are summing it up. Then we are getting the content cost function. If this content cost function is small, that means the content image and generated images are very similar to each other. The purpose, the work of our gradient descent algorithm is it will try to reduce this cost function. So per each epoch, we are trying to reduce the cost function. By making that, we are trying to make the generated image is similar to the content image. Now we have discussed the content cost function. Later we will discuss about the style cost function, which is the another part of the neural style transfer cost function.